Hello guys, welcome to another video. So in this video we will talk about the several design patterns when you create and deploy microservices on the cloud. Though writing microservices is maybe a simple thing to do, but when you talk about deploying it on the cloud, it has several topics which you need to have in mind. First is the microservice right sized? Is your domain business domain has been broken down into microservices that that take on adequate responsibility, not too much responsibility, right? So if too much response, if it's not properly sized, then making changes to such an application is difficult, and also it also reduces, if it is properly sized, reduces the overall risk in in an outage, risk of an outage of the application. Next is location transparent. So you don't want to hard code the physical location of your service instances. You want the client to get service instances through service discovery. That is making its location transparent, resilient. So how is it that you can, let's say, service is misbehaving and it consumes too much of your clients or consumers resources? So you want a policy that will fail fast, right? So next is you have the topic of repeatable. How will you ensure that every service instance that comes up has the same code and configuration throughout all the, throughout all the environments that it is deployed? Scalable. How can you use asynchronous processing, event processing, and events to make sure that the direct dependencies are minimized between your services. So depending on that, we'll talk about six different patterns. So first is the core microservice development pattern. So in this pattern, again, we'll talk about the service granularity. This your monolithic business domain has been broken down, and it's not too coarse grained. It should is it makes the service difficult to maintain and change over time. Fine grained, if it is too fine grained, then it means that it's essentially a dumb service that essentially does nothing but interacting with the underlying data store. And what are the communication protocols that we use? XML, JSON. We see that JSON is the choice for microservices, and it's the common choice for sending and receiving data between each other. And what about the interface design? Right, so it's just through interfaces that the developers are going to know about and are going to call your services. So you have to structure your service URLs to address that, to tell that intent, right? So is your services intuitive enough? How about the versioning of your service, right? And then you have configuration management of service. So how do you manage the configuration so that when you move between different environments, you don't have to change the application code or configuration? Then you have event processing. So how will you do event processing, asynchronous processing, so the dependencies between microservices are minimized? So that is the core development patterns for microservices. Then you have the routing pattern, right? So you want a microservice consumer to discover the location of the service and be routed to it, right? So for this, you have two different topics to cover: service discovery and routing. So so when so the client applications should be able to discover your microservice without having the location of the service hard coded in the application, right? And also, service discovery means any misbehaving services could be taken out of the pool of available instance services. Service routing is a single entry point of all services, so that there are several service policies, content policies, routing rules can be applied on these services and the instances. Right? These are nothing but the microservice routing patterns. Then you have the microservice resiliency patterns. So let's say you have a problem with one service, doesn't cascade and onto the consumers of the service. So you have client-side load balancing. So which essentially means that multiple calls to multiple instances of a microservice can be load balanced across good and active and well-behaving instances, healthy instances of the microservice. Circuit breaker pattern. So let's say that a service is failing and suffers from performance problem. How do you prevent that? That, and it also consumes resources as it serves a specific consumer. So you want to fail fast. So how do you fail fast? Right? That's a circuit breakers pattern. Then fallback pattern. So when a service fails, then you need a plug-in mechanism. So you can use alternate means of than the microservice. Right, then you have the bulkhead pattern. So this is let's say several microservices access several distributed resources. So how will you compartmentalize all these calls so that one service that is bad or decaying doesn't actually impact the rest of the application. Right. So then you have the microservices security pattern. Here we look at authentication. So how do you know that a client is who he says he is, and authorization where the client is has required permissions to undertake the action they are about to take. Credential management means rather than having to present your credentials for service call every time, how do you use token-based security standards like OAuth and JWT to create tokens and use them to authenticate and authorize the user. Right, then you have microservice logging and tracing pattern. So in this, so you have several microservices that are deployed or distributed, right? So it will become much difficult to debug and trace such microservices and find out what is going on with the certain with the application and the services. So you have to tie together all the logs related to a certain transaction. This is done by using a correlation ID, which is used across several service calls in a transaction, right? And a service aggregation. With this, you can pull all the logs related to a transaction and then make them available to a queryable database. Pull them into a queryable database, and you also have the correlation ID to assist with these aggregated logs. And then the microservices tracing. How will you visualize the flow of a client through several across transactions, transaction across all the services that are involved, and understand the performance characteristics of such services. Then last is the microservice build and deployment pattern. So here you say that you don't want to have, when a service runs for a longer term, there might be a possibility of configuration drift, and how you prevent it. So essentially it requires that you change the build and deploy process to have the microservice compiled, then deployed on the container image, and deploy, which in turn is deployed on the virtual machine image. Right. So these are, so you have you change your build and deployment pipeline. So microservices and the servers they run on are deployed as a single unit of work. Right. So that is build and deployment pipeline. So you change it so that the microservice and the server are deployed as a single unit of work. Infrastructure, you treat the provisioning of services. So provision of services also has a code to be executed and managed under source control. So do you want that infrastructure also has to come under source control? For example, take your Docker file. Should that come under source control? Immutable services. Once a microservice image is created, it cannot be modified. Phoenix servers. So Phoenix servers are more like longer the server runs, there will be configuration drift, and how you will ensure that microservices can be turned on a regular basis and recreated of a immutable image. Thank you.